Planet Earth, our vast home, is essentially a giant ball of semi-liquid rock, with a heart of iron as hot as the sun itself. It's a place where enormous amounts of heat, leftovers from its fiery creation and the continuous radioactive breakdown of numerous elements, desperately seek a way out. This relentless energy, with nowhere else to go, moves upward, driven by currents of rock that span thousands of miles. In its way stands the Earth's crust. To us, it feels sturdy and impenetrable, but it's actually as thin and fragile as an apple's peel wrapping around a core of fire. Subject to forces beyond our wildest imagination, this crust can crack open, leading to disasters far beyond the power of our most potent weapons, triggering eruptions that can shift the climate within a year and bury continents under deadly ash and gas. These events, known as supervolcanoes, are powerful beyond measure. But the question remains, how powerful are they really? And could they truly threaten the existence of humanity? Now, let's dive into the world of volcanoes. Our planet is adorned with a rich variety of these natural wonders, ranging from towering mountains that reach for the heavens to the more understated beauty of lava domes. At their core, volcanoes are fueled by two main sources. The first is found at the borders where tectonic plates meet. These plates are enormous sections of Earth's crust, locking together like pieces of an immense puzzle. Despite appearing slow to us, with movements up to 15 centimeters per year, this is actually a dramatic clash on a geological scale. This ongoing battle determines which plate will rise to form new mountain chains, while the defeated plate is forced down into the asthenosphere, a layer of superheated rock reaching temperatures of 1,300 degrees Celsius. On this adventure into the heart of Earth's fiery temperament and its explosive character, our goal extends beyond merely witnessing the sheer force and allure of these geological behemoths. We're set to delve into how they shape our world, influence our climate, and could even affect our continued existence. Join me as we embark on an exploration into the mesmerizing realm of volcanoes to uncover their strength, their enigmas, and the insights they provide into the ever-changing planet we inhabit. Beneath the surface of our Earth, temperatures reach levels high enough to melt rock. However, the extraordinary pressure from the mass of the planet keeps it in a superheated solid form. The tectonic plates, enormous pieces of the Earth's crust, have been absorbing water over thousands of years. As they sink into the deeper, hotter regions of the Earth, this water triggers chemical reactions that cause bits of the rock to melt into magma. Because magma is less dense than solid rock, it naturally rises towards the surface, collecting in sponge-like chambers just below the crust. When sufficient magma accumulates, it forcefully breaks through the crust, creating what we recognize as volcanoes. This phenomenon typically occurs under the overriding plate, marking a last stand by the plate being forced down, before it's completely absorbed into the mantle of the Earth. Another key driver of volcanic activity is what's known as mantle plumes. Imagine columns of incredibly hot rock that travel upwards from the boundary between the Earth's core and its mantle, reaching all the way to the surface. Although there's still a lot we don't know about them, mantle plumes could be thought of as the mantle's version of weather patterns, similar to how hot air rises and forms clouds in our atmosphere. However, these are not fleeting showers but monumental geological events that have been brewing for hundreds of millions of years, with rock moving at the slow but steady rate of a few millimeters each month. Unconcerned with the shifting tectonic plates above, mantle plumes force their way through the crust, creating volcanoes in places where you might not expect them. These volcanoes stay active over long periods, undisturbed by the ever-moving plates they break through. Turning our attention to the measurement of volcanic eruptions' power, scientists have developed a system to gauge the intensity of these natural spectacles. This system, the Volcanic Explosivity Index, VEI, employs a logarithmic scale to classify eruptions from the smallest to the most enormous. The VEI is adept at not only quantifying the volume of material expelled, but also at illustrating the overall magnitude of these events in a manner that aligns with our perception of their force and consequence. As we continue our exploration of volcanoes, bear this scale in mind. It serves as an essential tool, offering us a window into the grandeur and potential peril of volcanic phenomena. Diving into the Volcanic Explosivity Index, VEI, gives us a clearer picture of the scale of volcanic eruptions. Picture a VEI-2 eruption, which has the power to fill up to 400 Olympic-sized swimming pools with lava. It's quite astounding to realize that Earth experiences roughly 10 of these eruptions every year. Moving up to a VEI-3, the impact of volcanic eruptions grows considerably more serious. A stark illustration of this is the 2021 eruption of the Semeru volcano in Indonesia, which resulted in the destruction of thousands of homes. This event highlights the extensive damage that even a moderately large eruption can inflict on communities. Advancing to a VEI-5, we face eruptions that discharge massive quantities of material, amounts so vast they equate to cubic kilometers of debris, effectively becoming aerial lakes of molten rock. The 2022 Hunga Tonga Hunga Ha'apai eruption exemplifies this degree of explosiveness, propelling shockwaves around the world multiple times and causing tsunamis that spanned entire oceans. Attaining a VEI of 6 launches us into scenarios where eruptions have the might to reshape human history. The 1883 eruption of Krakatoa serves as a profound example. Over a period of 5 months, a series of eruptions from Krakatoa built up to a monumental explosion that fragmented the island, generating the loudest sound historically documented, a roar 10 trillion times more intense than a rocket launch, heard from half a globe away. These instances shed light not just on the magnitude and energy of volcanic eruptions but also underscore the Earth's ever-changing and unpredictable essence. As we delve further into understanding the volcanic boom meter, it's essential to remember the formidable forces at work under our very feet, sculpting the planet in ways that are simultaneously awe-inspiring and daunting. The 1883 Krakatoa eruption's aftermath reverberated globally in numerous ways. Tsunamis as high as 30 meters decimated coastal communities, and the massive release of gas and ash into the atmosphere caused a near 0.5 degrees Celsius drop in global temperatures. The phenomenon of red, dusty sunsets persisted for years afterward, serving as a somber reminder of the eruption's extensive consequences. Ascending to a VEI-7, we venture into the territory of supercolossal eruptions, monumental events that human history has seldom recorded. The 1815 eruption of Mount Tambora stands out in this category. Once a towering peak of 4,300 meters, it exploded with a force exceeding the Tsar Bomba by 400 times, catapulting 140 billion tons of ash and dust towards the heavens. This veil of particulates eventually enshrouded the skies in an eerie yellow hue. The aftermath, known as the Year Without a Summer, saw devastating crop failures and resulted in the deaths of more than 100,000 people, showcasing the destructive power of such massive eruptions. These events can cause worldwide famines and initiate prolonged cooling periods, altering the course of climatic history. So, what defines a supervolcano? Despite the dramatic flair of the term supervolcano, isn't officially used in scientific circles but rather was popularized by the media. It's important to note that not all eruptions from supervolcanoes reach the extreme magnitude often associated with the term. The true hallmark of supervolcanoes is their enormous magma chambers, which have been brewing and building pressure for hundreds of thousands of years. This pressure can eventually force the ground upwards by several meters before it's released in an eruption. Understanding the magnitude of supervolcanoes invites us to marvel at the extraordinary power these geological giants hold beneath the Earth's crust. They possess the capacity to alter landscapes and climate patterns on a global scale dramatically. The eruption of Krakatoa serves as a vivid example, with its massive tsunamis and the significant ash and gas release that cooled the Earth's temperature by nearly 0.5 degrees Celsius. The resulting red, dusty sunsets that lingered for years are a poignant reminder of the profound effects a single eruption can have worldwide. Exploring the scale of VEI-7, we delve into the category of supercolossal eruptions, extraordinary events that humanity has observed only a few times throughout its history. The 1815 eruption of Mount Tambora is a prime example of such a cataclysm. Once a majestic mountain standing 4,300 meters tall, its eruption unleashed an energy 400 times more powerful than the Tsar Bomba, propelling 140 billion tons of ash and dust into the stratosphere. This catastrophic event cast the world into a dim, yellowish haze, precipitating a year without a summer, devastating crops, and resulting in the loss of over 100,000 lives. Such massive eruptions demonstrate the capacity to induce global famines and prolonged cold spells, highlighting the formidable power of volcanic phenomena. Turning to the concept of a supervolcano, it's important to clarify that the term supervolcano is not rooted in scientific terminology but was instead popularized by the media. The reality is that not every eruption from a supervolcano reaches the catastrophic levels often associated with these events. The defining feature of supervolcanoes lies in their enormous magma chambers, which accumulate pressure over hundreds of thousands of years. When this pressure reaches a critical point, it can cause the ground above to uplift and eventually fracture, unleashing billions of tons of gas and ash at incredible speeds. Despite representing just a portion of the magma chamber's total content, such eruptions have a profound and lasting impact on our planet. Super eruptions are analogous to a pot of water boiling over. The sudden overflow leads to the formation of a caldera, a massive crater born from the collapse into the now empty magma chamber below. This cycle of pressure buildup and release is lengthy, potentially spanning hundreds of thousands of years until the supervolcano is primed to erupt anew. Interestingly, it's believed that the supervolcanoes dotting our planet may unleash such immense eruptions about every 17,000 years, a frequency surpassing that of significant asteroid impacts. The most recent of these supereruptions, known as the Oroanui eruption, took place in New Zealand 26,500 years ago. With the energy of billions of tons of TNT, it reshaped the landscape profoundly, launching an enormous volume of debris into the atmosphere. This exploration of volcanic activity, from substantial to the supremely colossal, sheds light on the sheer force inherent to our planet and the profound influence such events can exert on the climate, geography, and life. As we further investigate the history and capabilities of supervolcanoes, we're reminded of the vibrant and unpredictable essence of our world. Despite its immense impact, the Oroanui eruption is but a single thread in the vast tapestry of Earth's volcanic narrative, creating a caldera 20 kilometers across and instigating a significant, though brief, cooling period in the southern hemisphere. Yet, when viewed against the backdrop of supervolcanic activity at large, it represents a comparatively modest event. The Lake Toba eruption, occurring roughly 74,000 years ago, significantly overshadows the Oroanui event in both magnitude and consequences. This immense eruption unleashed about 5,300 cubic kilometers of material, depositing ash layers up to 15 centimeters thick across parts of South Asia, and causing a sudden global temperature drop of 4 degrees Celsius. The aftermath included a volcanic winter that may have spanned a decade and subsequent worldwide droughts persisting for centuries. The lengthy recovery period for Earth's climate, possibly extending to a millennium, underscores the enduring and profound impact supervolcanoes can wield over our environment. However, even the colossal Lake Toba eruption seems less significant when compared to the largest volcanic events recorded by science. Unlike typical eruptions, these were massive lava floods, blanketing extensive areas of the planet's surface. Among these, the Siberian traps stand out, having erupted around 250 million years ago. This prolonged volcanic activity, lasting for 2 million years, significantly heated the oceans, exceeding 40 degrees Celsius, and set off the Permian-Triassic extinction event, which annihilated over 90% of all life forms. The Earth's biosphere needed approximately 9 million years to recuperate from this disaster. These extraordinary volcanic episodes go beyond merely impacting the climate, they fundamentally redefine it. Their scale and effects are nearly unfathomable, marking pivotal moments that have redirected the course of life on Earth. Fortunately, such massive eruptions have not occurred in the millions of years since humanity's emergence. The history of Earth's volcanic activity serves as a potent reminder of the planet's formidable power and the fragile equilibrium that supports life. As we delve deeper into understanding these titanic natural forces, we not only unearth details about our planet's history but also gain perspective on our role in its continuing saga. So, is there a need to lose sleep over the thought of supervolcanoes? Definitely not. Despite their ominous reputation and the sensationalized scenarios often depicted in the media, the actual risk they pose is much more manageable. Consider Yellowstone, perhaps the most well-known supervolcano. It is indeed expected to erupt again, but the anticipated eruptions are likely to be on a smaller scale. Although they would be significant natural events, they are not predicted to wreak widespread devastation across the United States or threaten the survival of humanity. The probability of experiencing a VEI-8 eruption in the next few hundred years is under 2%. Importantly, such a colossal event would likely not take us by surprise. The real concerns with supervolcanoes lie more in their capacity for smaller, yet still potent eruptions that could have serious implications for our society. These require our vigilance and preparedness. To lessen these threats, it's vital that we keep a close watch on volcanic indicators, including shifts in magma chambers, surface bulging, and rises in temperature. Being alert to these signs can save lives, particularly for communities living near these giants. Furthermore, we are developing cutting-edge strategies to tackle the consequences of volcanic eruptions, such as methods for extracting sulfur and ash from the stratosphere to counteract the main drivers of climate change seen after previous volcanic events. Even more exciting is the prospect of harnessing the vast geothermal energy that lies dormant within these volcanic titans. By tapping into this natural reservoir, we have the opportunity to convert a potentially destructive force into a wellspring of renewable energy. Throughout history, humanity has consistently risen to the challenge of natural calamities, turning obstacles into opportunities. We are now accomplishing what was once considered fantastical, such as successfully conducting our inaugural asteroid redirection test. This culture of innovation and resilience reinforces the belief that with determination, there are no bounds to human achievement. Thus, even as the natural world stirs with untold power beneath us, there's no need for unrest. The creativity and perseverance of humankind are ever prepared to meet the challenges that arise from the Earth's depths. You can rest assured, tonight and every night, that a vigilant and progressive society is safeguarding your peace.